Welcome friends, in this third video on design of combined rectangular footing, part 4 actually. In the previous 3 videos we have discussed the part as we have calculated total load on the footing, area of footing, length of footing, width of footing. Then we have also calculated the net upward soil pressure. After that we have calculated the tile depth by bending moment criteria. In the last video we have calculated the portion till the AST minimum. I wanted to correct one of the mistake from me in the last video. I have taken 1.118 value here. This is the design shear which we have taken 1.118. It is always 1.8. Whenever it is not given we have to assume it as 1.8 Newton per. So you will get this value if you put 1.8 here. Okay, so just correct that. In this part we'll move towards the next calculation of area of steel. First of all, we'll calculate the area of steel under column A. So for that we require maximum bending moment calculated under column A, which was 118.67 kilonewton meter. This is calculated by us already. So if anyone of you is not understanding what I am telling in this video, please refer or watch my previous 3 videos so that you will understand this numerical. I am continuing the same numerical in this 4th video on design of rectangular combined footing. So for calculating the area of steel under column A, we need to write one formula of AST which is known to us. It is very popular formula for calculation of AST, FCK upon Fy in the bracket 1 minus square root of 1 minus 4.6 mu FCK BD square in the then bracket close, then it is B into D. So this is the formula for calculation of area of steel. And now we have all the values with us, so I'll write the values in the formula. It will be 0.5 into 20 divided by 415 is value of steel. 1 minus square root of 1 minus 4.6 into 118.67 into 10 raised to 6 divided by, it is 20 again, B is 1800 and D is 582 square. Again bracket close into into this. I'll write this as 1800 into 582. So this is our is 582. If you calculate this value, you will get, I will directly write what value you will get after calculating this whole. So if you calculate this, you will get 571.49 mm square. Now let's see what is the value of AST. This is the area of steel under A by calculation. Okay, now let's see what is the value of minimum area of steel required under any section. The value of area of steel, minimum area of steel calculated by us was 1404. It is not 140 point something, it is 1404 mm square, means 1404 mm square. So minimum area of steel at any section is this. So let's see what value we have got. This is value of area of steel obtained. AST is less than AST minimum, which is equal to 1404 mm square. Okay, so in this case we'll go for providing this value of area of steel, because if area of steel obtained or calculated at any section is lesser than value of area of minimum steel required at any section, then in this case we provide AST minimum at that section. So provide so the AST under A will be 1404 mm square. Okay, now to calculate the area area of steel to be provided under A, we need to take the consideration of area of bar, from which we will calculate the number of bars. So for calculating number of bars, assume, or we'll say directly, let's provide 16 mm diameter bar. So number of bars equal to 1404, that is total area of steel, divided by area of single bar, that will be pi by 4 into 16 square. So we'll check how much bars can be provided. It will be 6.98. Okay, so number of bars is 6.98. So let's provide 7 bars. Okay, so provide 7 bars of 16 mm diameter. This pi means diameter. Okay, so AST provided will be equal to 7 into 5 by 4 into d square. D is here, D is diameter of bar, or we'll write directly pi square. Okay, 7 into pi by 4 into 16 square. So I'll calculate that again. It is 1407.43 mm square, which is greater than AST minimum, which was 1404. So okay, now similarly we'll calculate the area of steel under column B. Area of steel under column B. So for that we have to take moment under column B, that is 585.03 kilonewton meter. Okay, so by using same formula we'll calculate the area of steel. I will write the formula once again. AST B 0.5 FCK divided by Fy into bracket 1 minus square root of bracket 1 minus 4.6 mu divided by FCK BD square then B into D. So this is the formula. If you substitute all the values correctly, you will get the answer as, I will just calculate that. I'll write all the values once again. 2415. For your understanding, I'm writing this 1 minus square root of 1 minus 4.6 into 585 into 10 raised to 6 divided by 20 into B is 1800, D is 582 again, its square, bracket close, 1800 into 582. So this will be, if you calculate this, you will get 2965 mm square. Okay, now this is greater than the AST minimum, which is 1404. So it is okay to provide the this area of steel. So I will find out the number of bars provide 16 mm 5 bars. So number of bars equal to 2965 divided by area of single bar, that is pi by 4 into 16 square. So let's see how much bars are there. It is 14.74, so we provide 15 bars. Okay, so let's provide 15 bars of 16 mm pi diameter under column B. Okay, now we'll see we'll calculate the area of steel for the part between the column A and B, which is carrying hogging bending moment. So the value of hogging bending moment calculated by us was, for third, BM was 765 kilonewton meter. So for that portion we'll calculate the AST again. Area of steel will be 0.5 FCK. Same formula will be there, Fy into bracket 1 minus square root of 1 minus 4.6 mu divided by FCK BD square. So B into D. If you calculate this, I will not substitute all the values here because I have given the example in, or I have solved sample calculation like this in previous two area of calculations. So I'll directly write the answer here. So it will be 3950 mm square. So similarly we'll provide 16 mm 5 bars here also. So number of bars will be equal to 3950 divided by 5 by 4 into 16 square. So if you calculate this, you will get 19.64. so provide 20 bars. Okay, so right here AST provided equal to 20 into 5 by 4 D, that is 16 square. It will be, I'll just calculate it, 20 into 5 by 4 into 16 square, it is 4021.23. It is 23. Okay, so it is greater than AST required. If this is AST required, so we have provided more than that, so it is okay. Now we have calculated the area of steel under footing A, footing B, and the part in between footing A and B for hogging moment, that will be in the top side of footing. After calculating the area of steel under column A, column B, and in between portion, we have to calculate the spacing for bars. You can refer the standards given in IS code for calculation of spacing. I am not going to explain about the spacing criteria of main steel in this video. You have to refer the IS 456 2000 for determining the spacing of main bars in this footing. Okay, it is very simple. They have given the three criteria like 3D, 300, and the calculated spacing. Minimum value of this three is taken for design. Okay, so like this you have to refer that, and you will calculate the spacing of main reinforcement yourself. Now we'll move towards the shear analysis. We'll calculate the shear force at various sections in the footing. So for shear analysis, I have drawn the representative diagram of this combination of footing and column loading. So this is the upward soil pressure, which we have calculated already. The value of this soil pressure, upward soil pressure, is 681.818, okay, kilonewton per meter. This is calculated by us previously. These are the factored loading on column A and column B. This is column A, this is column B. Now let's calculate the shear forces at various sections. So first of all, we'll calculate the shear force at SF at A, that is on left hand side of A. Okay, so the value of shear force at left of the A will be, so shear force, so we'll write like shear force on, I'll write here, shear force on LHS left hand side of A, it will be, here in this section we can check that on the left side there is only UDL, so 681.818 into this cantilever portion of footing, that is 590 mm. Okay, so in meter we'll write 0.590. okay, so if you multiply this you will get 402.27 kilonewton. Okay, now we'll calculate the shear force on RHS left hand side of A. So if you take section at this point, you will there will be UDL and this force in the downward direction, which will be negative. So the value of UDL is already known to us, that is 402.27 minus value of the downward load, that is minus 1.1500. So if you calculate this, it will be 1097.73 kilonewton. Okay, now we'll calculate the shear force on LHS left hand side of B. So if you calculate that shear force on left hand side of B, you have to multiply this 681 point. For simplifying the calculation, if you could take this loading for calculating the left hand side shear force, then it will be very it will be difficult, not very difficult, but we have one simpler way than this. We'll just calculate the shear force of right hand side first. So shear force on right hand side of B will be UDL, this UDL only. So 681.818 into the overhanging portion, that is 1.31 meter. So value of this will be minus 893.18 kilonewton. Okay, so then we'll calculate the shear force on LHS of B. So now here we know that there is only one load which will be added in this, so minus 893.18 plus, sorry, that load is in, so downward direction, but the section is at right hand side, so that's why it will be positive. So value of this will be, so it will be 1356.82 kilonewton. Okay, now if you draw this shear force diagram here, you know the shear force at this point is 0. Again, this shear force on left hand side of the A is 402.27. Here we have calculated it. then this value on right hand side of section is minus 10, it is minus 10 1097.73 again. Then it is changing here, it is having value of 893.17, then it is having value of 1256 here, and this will be the shear force diagram for the footing. Okay, so now we'll discuss how this shear force diagram is used for calculation or analysis of shear in the next lecture. Till now we have calculated the shear forces at various points, and we have also drawn the shear diagram. So thank you for watching this video. We'll continue with this problem in the next video. Thank you.